Hello and welcome to the Miko Bits Show, and I'm your host, Miko Bits. And I have Yuki Yuminaga. He is an analyst and an expert on these emerging technologies of zero knowledge computing. So, really excited to speak with him. So, Yuki, welcome to the Miko Bits Show.
Thank you for inviting. I'm very excited to have a conversation with you, Miko.
Yeah, wonderful. So, we're hearing a lot of stuff about zero knowledge proofs. I think this kind of emerging cryptographic primitive got a huge amount of attention through Vitalik Buterin. And he did a blog post where he was talking about some of the technologies that he's most excited about, right? So this is definitely on his short list of technologies. So, I guess first question is, what is a zero knowledge proof? And then I
Mhm.
think we'll get right into how such a technology can be used. But let's start with the basics. So what is a ZK proof?
Yeah, so at a high level, ZK proof can be explained in terms of like essentially the using the polynomial function, which is a function that allows people to extrapolate on data with only a few points, and then be able to figure out the rest of the points. So if you have, let's say, 2 data points out of the 10 within your knowledge. But with polynomial functions, you can extrapolate and say, okay, with these 2 points, I can sufficiently conclude that I know rest of the 8 points. So, so ZK knowledge, zero knowledge proof is kind of like the application of that. While using polynomial functions, they basically can verify and prove the validity of certain information that is not known, like those 8 that is not known, but can prove that with just the few information that you have on hand, which is the 2 that you have on hand. So that's why I kind of like describe it in terms of like it's an application of polynomial functions that is pretty well studied in the academic space.
Nice, nice. I saw a video that described it as one person being able to prove that they can see where Waldo is in Where's Waldo, right? So if you're looking at Where's
Yeah.
Waldo, you can say, I see Waldo, right? But they can prove it in a way that doesn't give up the actual location of
Yeah,
Waldo, right? So
exactly. Yeah, yeah.
they don't want to ruin the game. They don't want to no spoilers, right? But they can prove that they actually have it, right? Because obviously the thing you don't want is you don't want the first person to say, I can see where Waldo is. I don't want to tell you where he is, right? And that person could be lying, right? He could just be like, I
Yeah, yeah.
see him, right?
Mm.
And it could just be a game, right? He could just be like saying it, right? But
Yeah.
obviously, in the case of Where's Waldo, this isn't particularly meaningful because if someone lies to you about Where's Waldo, like it's not that interesting. Like who cares, right? Like it's a
Yeah,
game,
for sure,
right?
for
Whereas
sure.
whereas like I think what we're talking about now is a future where maybe many millions of dollars or billions of dollars will be riding on this game. So I guess the next question arises of like, when would you use something like this, and what is it being used for?
Yeah, for sure. So I think there are a few different contexts that we are talking about here, right? One is like more perhaps like the crypto native context, and the other one is like maybe outside of crypto, like Web2 traditional space, right? For those part that I think we are most like hyped with is sort of like the crypto context. I think that's where people are mostly known the ZK stuff for. And then within the crypto space, I think there are mainly like two aspects that I would consider to be very significant, impactful by the ZK stuff. One is the compression of the data, meaning that you can prove something much bigger size in volume without actually proving the entire thing, because you can just have this small ZKP, very compact ZKP that can be verified on chain instead of verifying a huge chunk of data. So there's the compression aspect. And then there is also another aspect, which is like as you mentioned, proving something that is perhaps private, that perhaps not the information might not be publicly disclosed, but then still be able to prove to a third party that it is verified data. So I think
Can
the verification of the validity of whatever compute or whatever data is another aspect. I would say is quite important.
So I'm super curious about, first of all, the data compression use case, right? So I'm really interested to try to understand a business use case for that, or when would you use this for data compression?
Yeah, so I think one of the most popular one in the space is uh, probably like a ZK rollup, or I guess a recursive ZK snark based rollups, like many that you probably know of, like a ZK sync and scroll and even like Polygon as well. Like a lot of them are using ZK to essentially compress the data that they have on their L2 and sort of like bundle them, batch them, and then represent it as a one ZKP, which would basically save a lot of cost for people executing transactions on the layer two. So I think that's probably one of the more famous slash prominent use case in the space that also got a lot of people's attention
Yeah.
innovating on this. Yeah.
So let me summarize this, right? So obviously, when you think about the state of a blockchain, right, you're really talking about a performance use case, right? So you're talking about layer two performance, and you're talking about like what has to happen is that the layer one is effectively rolling up a bunch of like transactions, right? So the concept of a roll up or performance is based on validating that these all happen, right? And part of that validation has to do with kind of compressing the
Mm,
state of the chain, right? Because obviously, if you want the entire chain state, right now I think the Ethereum chain state is very, very big now, right? And it,
mm.
it continues to grow, right? So I guess the thing that is interesting to me, one question that I have for you from the tech side is, why does that kind of a proof have to be ZK? Right? Like, why can't
Yeah,
you
yeah, yeah.
prove the chain state? Because it doesn't feel like there's any secrecy that's needed.
Yeah, yeah. So I think besides like the actual like cost deduction aspect, I will say the biggest benefit of using ZKP in the context of like proving the state of let's say your own layer one or proving the state of another layer two, for example, is the trust minimization aspect. Meaning that um, basically can inherit one of n types of trust model that is gonna secure the validity of the proof that you're providing. So in essence, we have this like a sort of like a two competing paradigms of security model that I think we are seeing in the space. And actually, maybe more than that. But I think those that I want to bring for comparison is like the crypto economic based security, where you have n of m assumptions where n supposed to be the majority. Should be the honest player in the network to make sure that
Yep.
the transactions can be validated successfully. While the one of n would be that at least one needs to be honest in order for the transactions or the state transitions to be validated successfully. And that would be the case for ZKP as a ZKP based application, as well as optimistic based application. So like OP rollups, etc. So they would
So
share the similar sort of like the trust model there.
so it means that each of the entities should not have knowledge of what the other entities are doing in order to create the strongest proof. Is that the idea?
Um, I wouldn't say that the entity shouldn't have a knowledge of what others are doing. It's more like it's I would consider it as more like you have a siloed security model where no matter what other people are doing as let's say the prover in this ZKP network, um it wouldn't be able to like prevent one person to successfully take this and execute it completely And
Yeah.
that is it is not so much about like not knowing what others are doing. It's more like you just simply have a very siloed channels of security in that sense.
Yeah, I see. I see.
Yeah.
So it enables you to chop up the work and make it harder for an attacker.
Yeah, basically. Yeah, yeah.
Interesting. Okay, so I guess clearly this is a scalability use case. I'm kind of curious to get your assessment of the different approaches, right? Because obviously there's different people using things like ZKVM. There's
Mm-hmm.
compatible and non-compatible approaches. So I'd just love to get your overview of like who's doing what.
Yeah, 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 for sure. I think to get some a bit more sort of like high level overviews. Obviously, as I mentioned, there is a bunch of like rollup projects, like layer
Yes.
two rollup projects, even like some sovereign rollups that are trying to use ZK, whether in the forms of like ZK VM, like what let's say like Risk Zero is doing, right? Or Polygon Maiden is doing, or ZK EVM, right? With Scroll and ZK Sync and a few others. And so there's that sort of like a layer two rollups space where they're focused purely on scaling of the network, scaling of the Ethereum layer one.
Yep.
There is, I believe, also a very big chunk of like ZKP effort that is going into the middleware, which I think is something maybe is not much discussed in the space yet. I think personally, I'm quite interested and also bullish on the those ZK-enabled trust minimized middlewares that are built on top of Ethereum. And so those middlewares may include on-chain oracles and data indexers and even bridges like those L1 L2 bridges. Mm.
Yes. Yeah, yeah. So those are definitely like really, really interesting cases. Oracle's bridges and rollups generally all have the requirement that a chain is able to assess and validate what's happening elsewhere, right? So I think
Yeah,
that's the general case.
yeah,
But let's go back to performance a bit, right? So you mentioned some of the parties, right? Obviously, folks like Scroll, folks like Polygon. I guess what are the differences in the approaches, and what do you think is what's your personal opinion on the kind of most fruitful approach? Obviously, modularity enables developers to make their own choices, right? But like, in a sense, broadly speaking, the entire class they're using similar approaches, right? So I guess my question becomes, it feels like optimism is different and it feels like ZK rollup is all similar, right? So like obviously there's a choice of whether you want to go with pure
mm,
EVM compatible or if you want to go with a slightly incompatible or completely incompatible, right? So
mm-hmm.
I guess my question is, what are the other trade-offs? Like what are the decisions that developers have to make in terms of getting L2 scalability?
Yeah, yeah, yeah. So I think it is the way I usually think about it is that yes, there is some like a bytecode level incompatibility that would
Yep.
occur with a lot of the as Vitalik kind of scaled from like the type 1 to sort of like the type 4, where the type 4 is kind of like the extreme where you have the fastest execution, but maybe not so as compatible as the type 1, where type 1 is you can almost consider as an EVM equivalent, and with a full compatibility, but with a much slower execution or slower performance in general. And I think my general take, and also perhaps a bit of preference there, is that um, I take L2 or those scaling solutions, including those L2s, are all like trying to provide faster and better performance, better scaling for Ethereum. And so my thinking in this is that I actually think that those who are providing the fastest executions and best performance is the one that would best capture the space in terms of like those community who are using those layer twos, and in consideration of those like compatibility issues, right, associated with, let's say, some may claim that, okay, type 4, type 3 are not as compatible, bytecode level compatibility is lacking, etc. Because of the fact that they use compilers to a different assembly languages and whatnot. I personally do not think that is a very big issue, meaning that I think it's only an issue at maybe at the very beginning for some of the developer tool who requires it, where it requires bytecode compatibility to work, that may break because there's no bytecode compatibility when you move on to, let's say, ZK Sync, for example. But I think that is short term problematic, or as in short term a bit of a troublesome. But I don't think it long term is an issue where people would say that, okay, I'm not going to do things just because there's a bytecode compatibility issues. If anything, if it
Yeah.
yeah, I think it's a problem that can be solved over longer term once the dev tooling around the layer twos can be a lot more complete, and hence why my kind of choice is sort of leaning towards more optimized for performance, and not so much uh, leaning on like, or so much putting weight on those compatibility
Compatibility.
aspect. Yeah.
Yeah, yeah, yeah. So just for the audience who hasn't caught up with this, like, Vitalik.ca, you can look at the blog post, and Vitalik has a blog called The Different Types of ZK EVMs. So he provides a scaling system where he describes, types 1, 2, 2.5, 3, and 4, So if you look at this kind of type 4 EVM, right, there isn't compatibility of Solidity, for example, right? So you need stuff like Nethermind Warp project that cross compiles Solidity to Cairo
Yeah, yeah.
on Starkware,
Mm, mm.
or ZK Sync, right? So I think what Yuki's pointing out is he's pointing out that, like, that probably the developers are smart, in general, right? And that I think you're probably, so I think what he's saying that, like, the lazy man's performance, may not be the winner because developers are smart enough to deal with it, right? They're going to deal with this so that they can get a much, much faster result.
Yeah.
I think that's the Yuki thesis, right? Which
Yeah,
is,
yeah, basically, yes.
if you can put in a certain amount of human intelligence and get faster machine speed, then people will do that. I think that's the take home lesson. I mean, obviously, a lot of the ultimate design decisions around modularity are,
Mm,
it depends what you're trying to do, right? But, like, but I would say that, like, generally speaking, people don't give up on faster, cheaper applications, right? So I do think your logic makes a ton of sense. That's cool. So I think that's broadly, so what's your kind of forecast about the future of layer 2 scalability, right? Like, what do you think is going to happen, right? Is it going to be app chains, or, like, what do you think is the kind of final steady state of kind of Ethereum class applications? Like, do you believe in the Vitalik endgame blog post of centralized block production with decentralized validation? Or how do you see the final steady state of, like, blockchain performance and modularity?
yeah, yeah, for sure. I think that question is super broad, so I guess we'll kind of like split into maybe two parts. One is the sort of like the roll-up space, and then the other one is the block production space. So let me kind of like first talk about the the roll-up space. I think in general, like, we've been seeing a lot of like roll-up specific applications type of infrastructure coming up, right? I think there's a roll app as a concept that is kind of emerging in the space, where people are like, oh, you can use this SDK to spin up a bunch of rollups. Maybe you use Ethereum native DA, or maybe use external DAs like Celestia or EigenDA, for example. So there are a lot of like optionalities around how you can build rollup is popping up as well. And furthermore, you have Optimism superchain, Arbitron's orbit, and then you have ZK Sync, what's it called, hyperchain or layer 3 concept, I guess, that are also popping up. But basically, you have so many like ways in which you can now build rollups on top of rollups, or the, SDK type of projects. Now, my general take in this matter is that I think there are going to be a burgeoning ecosystem of roll app in the future, besides those generalized L2s that we see right now. However, perhaps my take is that perhaps the market might be a bit overestimating how many of them would exist, meaning that I think the hype is a bit too much, in my opinion. And the
Hmm.
reason for that is because the L2, as in existing generalized rollups, should be catering for a majority of the application need in terms of
Okay.
the throughput, if they do their jobs right. Because if they don't, then sure, maybe there are some other solutions. But in general, I think a generalized L2 should be able to cater for the majority of the need, while the rest of the maybe 20-30%, where they have to have some specializations of their functionalities, or maybe they need some sort of like more customizability around their sequencers, around their node who are running the sequencers, may prefer to use their own rollups as a execution layer instead. So I think if you think from that perspective, frankly, it's still a bit hard to say how many roll would actually exist, and if a lot of those roll app SDK type of projects can even turn significantly profitable, given that they're also like running as a SaaS business type, and there's already competitors framework from existing
But what
generalized
about
L2.
something like, so I think, what about something like app chain, right? Because if you think about the economics,
Mm,
right, the economics of this kind of horizontal role app
mm,
strategy is dependent on the apps, right?
yep.
Whereas like if you have a pure app chain method, then the monetization happens at the application layer.
Yeah, yeah,
So I
yeah.
guess what are your thoughts about that?
Yeah, so um, because I think in many ways, raw app is actually very similar to app chain. In that a lot of the time, if you're talking about like sovereign rollup, it's essentially similar to like Cosmos app chains in that they would have need its own consensus, and that it would have to rely on its own economic security to guarantee the security of the chain, guarantee the consensus is valid. So in many ways, those can be mentioned in a very similar framework. And frankly, the biggest issues that I have in general with sort of like going with the app chain thesis is that I don't believe that a lot of the applications can generate enough economic values slash incentive without significantly diluting their token values uh, to secure the network. Because in a sense, like if you think about how Ethereum as a layer one, Ethereum as a chain is secured uh, as a layer one for all the validator nodes that are running for Ethereum, it's really like the activity on Ethereum that is like driving the values creations, like the essentially the gas fees and the captured MEV on the chains. And without that much values generations, uh, it's hard for me to really imagine like how one applications can sustain that amount of like value
All right, so
incentives.
let me throw my cards on the table,
Yep.
right? Which is I'm actually thinking about an exchange, right? So, I think the idea of the exchange that I'm thinking about is kind of almost like world's fastest exchange, right? So if
Right.
you think about this, it's an order book,
Mm-hmm.
right? And in a sense, like the thing that happens with it is that you effectively sort of decentralize the ownership, right? And you don't necessarily decentralize the execution, right? So the exchange execution,
Mm,
which is order matching, right, is not decentralized. It's
mm,
distributed, but it's not decentralized, right?
mm-hmm.
Because why would you do that, right? It doesn't benefit you, right?
Yeah,
So
yeah.
in a sense, the idea becomes that the validator function on the exchange is more like audit. It's more like an audit function, than it is sort of like a proper consensus,
Hmm.
right? So I guess I'm. So what do you think about that design?
Yeah, 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 for sure. I think it might take a distributed chain is fundamentally very different from decentralized chain.
Correct.
All right, like I think
Correct.
these
Correct.
two are running on a very different trust or security model in a sense.
Correct.
So I think but one thing I do agree on is that right now, if you ask, let's say like DYDX to run
Yep.
completely on chain, like that just
Yep.
is
Good
it's just
example.
not possible, right? That's not gonna work. So if they are wanting to go to its own execution layer and try to like achieve that or get closer to that, then yeah, I think that's fair within the framework of what we have today. It's just that I would argue that a lot of the exchanges who are running or trying to run on chain are also like quite limited in numbers, meaning that I don't think there will be hundreds of exchange that are doing similar stuff. I believe there will be one or two exchange that would successfully capture that market, and the rest would kind of get
Totally
competed
agree.
out. Yeah. So I think that in the case like app chain or roll app specific for exchanges is something that I do think would make sense as well. And
I
frankly,
think
yeah, yeah,
I
frankly,
just the
oh
reason
yeah.
why the reason I wanted to poke here on exchange,
Hmm.
right, is if you look at kind of like so people have this idea of like on-chain gaming, right, which I'm a skeptic, right? So if you think about on-chain gaming at scale,
Mm,
at sort of potentially mega scale, right, what you have is you have a property where there's a necessity for scalability of performance that's kind of linearly proportional to the user, right? That you have more and more users, so you have more and more transactions,
right.
right? And that's it, right? So to me, that particular class of application scalability, I think, is maybe less interesting than something like exchange, right? And the reason why I think exchange is so interesting is that because of things like high frequency trading,
Mm,
right? An exchange, even with a fairly small number of users, is still going to benefit from HFT,
mm,
right? So in a sense, an exchange, regardless of the volume or number of users, is still going to want to pursue being the fastest possible software,
mm,
right? Regardless of the user base, right? Now, obviously, if you pursue being the fastest and you don't have any user base, it's obviously not economic, right? But
right.
like my point is that the driver of the desire to be fast is not directly tied to the user base. It's tied to just an inherent desire to be the fastest, right? Because in a sense, like the fastest exchanges will attract HFT, like they'll attract
Yeah.
the kind of the lion's share of the market volume.
Yeah, I agree. And I would also add that frankly, like the security associated with the gaming specific chain isn't as big of a high stake as ones like
Agree.
like transacting billions of dollars of execution volume on like exchanges
Totally
or
agree.
yeah. So I think there
my
is a
favorite
need.
my
Yeah.
favorite my favorite argument on gaming is if you watch kids playing in the yard, right? Well, you'll find kids arguing like, I shot you, and the other kid's like, you missed, and like the thing that's funny is when you actually go to real video games, nobody ever argues with the game engine, right? So
Right.
I guess what I'm saying is that there's never really a trust problem, right?
Right.
Which is that Web 2 game engines are trusted. They're trusted more, in some ways they're trusted even more than humans, right?
I
Like if
agree.
you
Yeah,
look
yeah,
at
yeah. Mm.
kind of sports, right? In sports, you have these crazy video playbacks, right? Like you could replace, referees and umpires with an AI,
Yeah.
and the audience would probably be happier, right? They would
Yeah.
probably be happier. Like the Super Bowl basically went down basically on a holding call against the Eagles offensive holding, right? And like the audience was mad. They were just super mad, right? Because
Right.
they were like, that's completely out of,
Right,
you
right,
know, they
right, right.
the referees just ruined the Super Bowl. So anyhow, long story short
Yeah, yeah, yeah.
is I'm skeptical about the game the game
Yeah,
rule
yeah,
engine use
yeah,
case.
for sure. And to kind of continue on the block space side of things.
Yep.
So I
Yep.
think you mentioned about like the centralized builder and the decentralized validation of the blocks for Ethereum.
Yep.
And frankly,
Yep.
I've been talking about this for quite a long time as well, but I do not, I'm not on the camp of that view. Uh, I'm actually
Mm.
more on the camp of like, okay, we have a decentralized validators, great. Let's have a decentralized builder, decentralized sequencer for the block productions of Ethereum. And so I've been quite a big advocate for decentralized block builder side of things for Ethereum for quite a bit as well. Mm.
Yeah. Interesting. Interesting. I mean, I'm mostly quoting from Vitalik's blog post called Endgame,
Yeah, yeah,
right?
yeah.
Where where the idea becomes that block production becomes centralized, right? And
Mm,
validation becomes trustless and
mm,
highly decentralized, right? So in a way that's almost like I would call it an audit model, right?
right.
It's a model where you know you have this kind of very hot central actor,
Mm,
and then you just have these like auditors that are kind of watching and making sure it doesn't go bad.
yeah, for sure, for sure. And frankly, talking about like the ZK stuff, like obviously there are still a lot of open ended questions and research to be done in this space. And it, in the context of like block productions, there are actually interesting ways in which like ZKP can be used to, let's say, create a more trust minimized decentralized block production schema that is not relying on any tokenomics or any consensus, but just based on the cryptographic guarantees. So there are definitely ways in which those ZKPs can be used within the context of block sequencing. But due to the current sort of like the performance cap or the performance data that we have on those, like even some of the most like beefed up ZKP with strong prover, it's still hard to have a very uh, fast latency sort of use case for ZKP. So we'll probably take a while until we see like ZKP can be used in the context of like block sequencing, I believe.
Yeah, I mean, it does seem like the average benchmark is kind of like ZK validation is like 1,000 times slower than just straight through execution. So someone was saying, I think it was actually I was on a panel, with Risk Zero,
Mm.
and the Risk Zero guy was he was basically saying if you take your M1 MacBook Pro, right? ZK can turn that into a Raspberry Pi, right? which which it sounds bad,
Yeah.
right? It sounds kind of embarrassing,
Yeah.
but to be honest, it's actually not that bad. And the reason why I say it's not that bad
Mm.
is I can take 1,000 M1 MacBook Pros, right, and turn that into like 7 TPS, or I can turn, like if you want full consensus,
Right.
it's even more extreme, right?
Mm.
It's even more ridiculous.
Mm.
So, so I would say that like it's all relative, right? But we're talking about like many, many orders of
Yeah,
magnitude.
I mean, you can also argue that, well, okay, sure, there's that performance discount, um, but it is also equally difficult, or perhaps even more difficult, to accrue enough economic value for an ecosystem, for infrastructure, or just like general middlewares to be even considered safe. Like, that. So I think you can say that, oh, okay, well, with ZKP, with just like a one or two strong machines that can sufficiently provide securities for whatever middlewares that they're integrated with.
I think one of the things that's fairly obvious to me, and something that I think is really an important core principle that we're elucidating here, is that lack of trust is actually expensive,
Yeah.
right? Is that that's the thing, right? Because in a sense, if you could just trust one counterparty, then everything becomes super cheap,
Yeah.
right? And so, so I think that the blockchain optimization is an infrastructure where you don't need that, where you don't require the
Yeah.
trust, right? Which I think is why everything is so freaking expensive.
Exactly. So I think to some extent, if we continue to see optimization in the ZK space, and perhaps in the future with ASICs coming out and whatnot, obviously we don't know how exactly the cost is going to look like, but my expectation is that the cost will decrease quite significantly, as those gets more adopted. In that case, we may see a future where a ZK-enabled middlewares or infrastructures may generally incur less cost than ones that relies on cryptoeconomic incentives and security.
That's fascinating. I mean, I was talking with someone who's at Ingoyama, one of the kind of
Mm,
hardware
mm, mm,
ZK accelerator
mm,
companies, right? And, it's really interesting the way that the mindset is there, right? Because in a sense, one of the big problems with hardware acceleration of ZK is that there's actually so few applications that are actually heavy users of ZK proofs, right? Like it turns out that really one of the most dominant users of ZK proofs in the world is Filecoin,
oh
right? And
yeah.
it turns out that kind of the right because I believe the use case is that they just don't want people who are storing data to be able to read the data, right? Which is a privacy issue. I think that's
Yeah,
the issue. I'm not sure
yeah,
that's
I
the issue.
believe I think it's their seeding process. Yeah, I think it's their seeding process where they kind of encode the data that is stored. So that as you said, yeah,
Yeah.
as you said, you don't want to, have it leak to anyone, basically.
Yeah. Because otherwise, people who are doing Filecoin would just be reading everybody's files, which is
Yeah,
sort of not it's a little suboptimal. So I would say as a storage medium. So I think that the thing that's really interesting from the ZK kind of cryptographic primitive, I think you mentioned a couple of use cases. One of the ones that I'd like to poke on is sort of the
mm,
bridging,
okay.
right? Because
Mm, mm,
obviously, we've seen incredible dynamics in the
mm,
market around things like the wormhole
mm,
bridge,
mm.
being hacked and then being reverse hacked and, all this excitement, right? So, I think bridging is definitely a very
Yeah.
vulnerable spot. So, do you feel like the future of bridging is ZK? And like, if so, are we going to have kind of unhackable decentralized bridges anytime soon? Like, what's your belief?
Yeah, I think I for the unhackable bridge, to be honest, like it's gonna be super hard because being generally having a ZK bridge, like while the architecture could be simple, but the proof itself may incur, like the ZK proof itself may also incur additional bugs and ways that essentially allow people to
Agreed.
hack. And you can argue that over majority of the hacks that happen on the bridge space has been just simply like negligence on the developer side, right? Like there's some little bugs or
Agree,
right,
agree,
like
agree, agree,
yeah,
agree. If you give your private keys away, you're kind of not going to do well in
yeah,
life.
like as in like it's social engineering. It's some like sloppy development work. It may be some bug issue on contracts. So in many way, you can also argue that while ZK Bridge is great, and I think ZK Bridge is super cool, and I wish and I hope that the ZK Bridge would eventually be sort of like the most secure type of bridge model as they get mature. But on the way leading to that, I can also see ZK Bridge getting a lot of like attacks and those bug issues that would cause them
Hey,
to yeah.
I have a design. I have a design. So I have a design for a bridge that is 100% decentralized and 100% secure, right?
Okay.
It just has a latency of infinity. That's my design, right? It's a
It
trilemma
will never
solution.
fail.
So it works perfectly. It cannot I can mathematically prove that it won't fail, right? Because it takes an infinite amount of time to do anything, right?
Actually,
So
yeah.
yeah,
Yeah. But
yeah, it
yeah, but
works.
I think currently, just assuming that the practicality of ZK Bridge, like those hacks and bugs, does not happen, then in my opinion, yes, their bridge design is definitely more trust minimized than a lot of the other existing bridges in the space that are, let's say, like based on some cryptoeconomic securities or based on some trusted, like, guardians, whatever, like for wormholes, that would be the case. And or even just like some simple multisig, right? Like, which is the case for,
Yeah.
lasers, etc.
I mean, I think so far. I think so far, like centralized bridges have kind of been relatively secure, right?
Yeah.
So, like in a sense, that's an approach, right?
Well,
Is basically a centralized bridge is basically effectively as secure as a centralized
I
wallet,
actually
essentially.
I would kind of push back on that, because arguably you can
Okay.
also say that centralized bridge is also where a lot of the social engineering happen. Like, for example, okay, maybe not like social engineering, but basically like kind of, hacked their way into the system. Like, for example, the Ronin hack was definitely
Yeah.
a sloppy work of those guys who had their the test servers out and people can play around. Uh,
Yeah, so for the
yeah.
audience, I mean, for the audience, so my understanding was that there was a PDF that was kind of like a job description of some sort that was executed on an engineer's laptop, and that it had malicious code execution rights. So I think that was part of the hack. I don't know. We should definitely go look up the Ronin Bridge hack and try to get some of the
Well, actually,
details. But
besides the
it
Ronin one,
definitely
there's also the Harmony bridge, and I believe the
yes.
Harmony bridge from the auditing friends that I heard from was also a social engineering hack as well, apparently. So yeah, I mean, it was a multi-sig. So you got some bad PDF downloaded on your computer, and boom, your multi-sig, your key is gone, and now they have the majority
Yeah.
control of your bridge.
They have five of
Yeah, yeah,
nine, right?
yeah,
That was the Ronin
yeah.
case.
So I think again, like I would argue that those centralized bridges aren't necessarily safer. It's just that it's easier to go to market, and it's easier to deploy, and it's a lot more. You can argue that scalable, because you don't have to scale the trust assumptions. You just have to scale the deployment and the interfaces where it's active on different chains with the same security guarantees that you had, which is the multi-sig or whatever. So I think, yeah. And I would also put out that in the case of like ZK bridges, depending on the design, obviously, because there are a few different ZK bridge designs in the space. But the one core aspect, one fundamental aspect of ZK bridges is that you are at the end trusting on the security provided by the cryptographic proof, which is basically the math. Like, if the math is correct, then you are good to go. But if the math is not correct, then you got in trouble. So essentially that's the way I put it. And so now the kind of futures of bridges that I'm looking forward to is like, okay, it's whether we trust the human or whether we trust the math. And I would love to trust the math.
Ha,
That's kind of like
that's
the way
good.
I think about it as well. But however, having said
That's
that, there are a few different considerations. I guess you can think of as like a challenges faced by this ZK Bridge stuff. One is the sort of extensibility of light clients, especially in the context of Ethereum light clients. Um, because
yeah.
currently the way that Ethereum light clients is working on is based on this thing called sync comedy, which is I believe was like a 512 or 256 rotating set of validators that are constantly communicating with light clients that are essentially fetching the block header from the network and relaying that block header over for performing the ZKP. Now, that means that your underlying security assumption is one, relying on the staked Ethereum, obviously, but also relying on that set of think comedy validators, which is only a subset of broader Ethereum nodes that exist in the space. So I think there might be a bit of a misconception generally in the space that, like, having this think comedy model for light clients based bridges like ZK bridges isn't necessarily inheriting or automatically inheriting the entire security backbone of Ethereum. But it's in fact inheriting the security of Ethereum and subset of validators
So
as part of the Ethereum.
so let me understand. So what I'm hearing you say is sync comedy. Is that
Yes,
the
yes,
right
yes. Sync
word?
comedy.
What is the
Sync
word that?
sync comedy. Yes.
So why is it a
Oh,
comedy?
well, because it's gonna be
Because it's not a tragedy.
oh, no, no, no. Committee as in like, the committee, like the
Oh,
council,
I
right?
see.
Yeah, 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 yeah,
Agreement.
yeah. The council.
Yeah.
Yeah,
Okay.
so yeah, yeah,
Sounds
the
good.
sync committee
Okay, I'm back.
exists because it would be quite challenging, like just in terms of the network payloads and also the traffic loads, to have every validators on Ethereum to be in agreement and sync with light clients that are running outside of running in tangent with the full nodes on Ethereum. So what they came up with as a solution is that, okay, instead of having thousands of validators participating in this light client communications, let just have a subset of it to specialize in communicating with those light clients. And that subset is like a rotating subset that is picked randomly from the entire
Yep.
pool of validators in this Ethereum space. And yeah, and
Makes
and
sense.
obviously they tried a lot to make sure that, okay, you would inherit as much security as possible from the underlying entire Ethereum validator sets as well as the Ethereum stake. However, it is also worth noting that you would have somewhat different trust assumptions using light client based on sync comedy versus just like fully inheriting the security of Ethereum. And I think that's something to be noted for sure, especially dealing with this kind of like light client based ZK bridges.
Got it. Amazing. So let's go zoom back into the future just for the kind of closing note, right? So to me, I feel like this, right? Which is we looked into things
Mm,
like bridges, right? It feels to me like the bridge conversation is bridges have other problems, right? So in a sense, like there's no ZK magic wand for bridges, right? That bridges will continue to have problems as long as they're kind of bridges, right? So it feels like the juicy area is probably more kind of things related to performance and
mm, mm,
scalability. So I guess I'm curious, like your perception, right? Because for me, if I think about the future of the use of ZK for
mm,
scalability, like that feels incredibly promising, and it feels like the result will be that application developers will end up with like lots of
mm,
options
mm,
and lots of really wonderful good
mm,
options, right? So it feels like that in a sense the L1 L2 thesis of Ethereum, it feels like it's close at hand, right? It feels like that developers will have their opportunity to have both secure settlement layer and
mm.
high performance layer, so they should be able to have their cake and eat it. That's what I project in the future. What's your thought? What are your thoughts about the
Yeah, I
future?
think I definitely agreed. I think the scaling is still sort of the big heavy lifting that ZK is doing right now in the space. And I think I'll just add that in general, another big aspect of ZK that I really bullish about is really the trust minimization aspect, which I'm currently also working on a paper to kind of like have more concrete things out for everyone to read. But essentially, I think when talking about ZK, scaling is great, but let's also talk about trust minimization, which is something that I feel like is very core to the Ethereum ethos as well, given that we're all striving towards the trustless blockchain ecosystem as well. So instead of fragmenting the cryptoeconomic securities while having multiple layers of infrastructure on top of it, where each infrastructure is kind of like bootstrapping their own securities, why don't we either go with the sort of like the ZK based trust minimized model, or perhaps maybe you can explore like the restake model, like leveraging on top of Ethereum. Either way works, but I think that's a very interesting experiment that I'm seeing, and I'm personally quite bullish on those trust minimization provided by ZKP.
I'm looking forward to the paper. So, where should audience members follow you if they want more exciting thoughts and papers and content about the future of novel cryptographic primitives?
Okay, now I wouldn't say that far, but I would say maybe I think my Twitter is okay. Usually I post my Substacks and some threads on my Twitter at Ballsy Alchemist. So yeah, people can follow me on that as well.
Yeah, that's pretty funny. We'll try to get that printed in the show notes so that you guys can just click and follow because I definitely get a lot of ideas, a lot of amazing thoughts, and a lot of great alpha from following Yuki. So appreciate you
Thank you.
joining the
Thank you
show.
very much for inviting. Thank you.